We're going to treat three main points: the preview, safety and viability study, the implementation of the service, operational information. First off, the environmental study of the beach for maximum efficiency of Auxdron, the study of safe flight zones, the study of GPS signal quality and interference, and the selection of takeoff and landing point. Here we see the example of Puerto de Saguntos beach in Valencia. We'll take into account the total length of the beach. The study of GPS signal quality and interference will identify dangerous zones. We'll take into account the main wind streams, both lateral and rip currents. We will decide the operating zone of the drone so that we avoid flying over swimming zones and minimize possible risks. We advise placing Auxdron in the center of the beach, so that it takes the same time to reach each of the furthest points of the covered zone. We advise using beacon lanes for sea vehicles, as they are the safest zones for the drone to enter or leave the sea.
We'll begin with the assembly of the arms. It's very important to remove the cap only when we're about to proceed with the assembly. We'll introduce each arm in its corresponding position and we'll secure them with its screw system. Arms 1 and 3 are tightened counterclockwise and 2 and 4 are tightened clockwise. It is important that when we introduce the arm in its corresponding location, we tighten it only if its placement is correct, to avoid damage because of a forced connection. In this image, you can see the propeller's direction of rotation in the coaxial system. The top motors are colored blue and the boat motors are colored red. We recommend to place the aircraft in an elevated platform, minimizing the exposure to humidity, sand, dust and salt. For safety reasons, we advise to make a perimeter around the takeoff and landing zone to allow access only to authorized personnel. The takeoff maneuver and the approach to the sea should be made at an altitude of 2.5 to 8 meters. These heights will be dependent on the safety study performed by the operating entity. We'll provide our clients with a maintenance manual of the aircraft, which contains with great detail every revision and check that needs to be done every day, or after a certain amount of flight hours. In the daily revision, before the service begins, there will be certain checks that will need to be performed by the pilot or the person responsible of the flight. They'll need to check the overall functionality of the aircraft and more specific parts like the propulsion system, the connections, and watertight joints, among others. The life vest will be wrapped around by a 4-meter long rope. The first loops of this rope will be done with a spacing of 2 centimeters. The direction of the rolling will be different for each life vest to ensure a successful deployment. The final loops of the roll will be done with a spacing of 1 centimeter. When placing the life vest in the payload module, the CO2 bottle will be centered and facing forward to achieve a balanced center of gravity. First, we anchor the rope to the securing fuse. Then, we place the flotation device in its correct position and connect the securing strap with the release system. The payload module has 2 flotation devices easily replaceable. We've optimized the deployment system so that it works with the landing gear control of the DJI Lightbridge 2. The securing fuse will only release the rope with more than 3 kilograms of tensile force. The release maneuver will be performed by the pilot after a successful delivery to the victim or to preserve the safety of the aircraft and its surroundings. For the deployment, we'll place the aircraft right above the victim and release the life vest at a height of 4 meters. We'll decrease altitude so that the valve makes contact with water and inflates the life vest. We'll climb to 4 meters again to approach the device directly to the hands of the victim. Once it is within the person's reach, we'll deliver the life vest and make sure that he or she has secured it. Then we'll climb vertically and the fuse will release it from the vehicle. On a daily basis, before starting the service, a functional in-flight test will be performed to ensure the correct basic functionality of Auxdron. First, we'll take off and perform a 30 seconds stationary flight at a height of 3 meters. Then, we'll test basic roll and pitch maneuvers. Followed by climbs, descents, and 360 yaw turns, both clockwise and counterclockwise. Whenever it is possible, we advise to land the aircraft on the elevated platform to minimize maintenance costs.
In this video, we're going to see how to prepare a waypoints-based flight path using the DJI's GS Pro app. Once we've opened the app and connected to the aircraft, we'll start setting up a mission. We tap here and we see that we're offered different choices such as photo mapping, virtual fencing. This is oriented for geomatic projects, filming, which is not our case, so we'll only set up a route using waypoints. We'll do it manually by tapping on the screen, but we could also set up the waypoints recording actual positions of the drone from a previous flight. We would fly and make sure it is the desired position. In this case, however, we'll only define it by tapping locations on the screen.
So we hit tap and we see our current location. We then start setting up the mission. In this case, we'll keep it simple and place only a couple of waypoints. We'll place one here, and the last one over here, just a small square. Now we'll see the options were presented on the right side of the screen. First off, we can control the velocity of the aircraft between the waypoints. We'll leave it at 10 km an hour so that it flies slow and clear. We can also control the altitude at which it will fly over those waypoints. We'll set that to be 20 meters. Here we control the aircraft heading. It can be either course aligned or we can define it in every waypoint. For example, we can say fly over this waypoint at a 90-degree deviation. In our case, we'll set it as course aligned. We can do the same for the gimbal pitch angle, which we won't modify in this case. We can define too the aircraft behavior in every corner. It can fly over our defined waypoint precisely, or it can do a curved trajectory that joins smoothly our defined paths. In this case, we'll set it to perform as straight lines. Finally, we can decide the aircraft behavior once the mission ends. We'll choose hover, so we'll need to land manually. We could, on the other hand, use the return to home feature or make the vehicle automatically land on the same spot. We'll name the mission Test 2, for example. We could save it and use it in the future if we so decide. On the top right, we can see useful flight information, like the number of waypoints, the flight length, an estimate of flight time, and the number of batteries that we need. Before starting, we'll need to check that everything is okay in the Prepare for Flight screen. Finally, we'll tap Start to Fly and we'll begin the mission with the settings that we previously set. We have video feed from the camera during the whole mission, and we have control over the sticks just in case we want to stop or modify the mission. As an example, we'll input a command to reduce flight speed. We gain control over the translation, and we could even stop or abort the mission. We'll let it continue though. As you can see, now the mission has ended, and we regain full control of the aircraft. Now we could land it or continue with another mission.